Hey friends, like we said in the last video, there are tons of STEM topics at play in the car project, so let's dive right in. The first one is actually one that doesn't necessarily relate to the car that you'll be building, but we thought it would be neat to pass along how real cars that you see on the road work. It's called the internal combustion engine. There are so many moving parts in cars that we often forget about. On your screen right now is what's called a piston cylinder. You will find these in any gas-powered engine. We will explain a little bit more about how they work here shortly, but what makes them so unique is they take the up and down motion from the top part of the system and turn it into rotating motion down at the bottom, which is then transferred to the wheels. These are called 4-stroke engines because there are 4 strokes for every one of its cycles. The first stroke is called the intake, where the top left valve opens, the piston goes down, and a mixture of air and gas from the tank enter the system. After that is called the compression stroke, where the piston goes back upwards and compresses that air and fuel mixture into a very small area. But here's the cool part. In what's called the power stroke, the spark plug at the very top ignites that mixture of air and fuel and gives it a very high temperature and pressure and forces that piston back down again. Finally, in the exhaust stroke, the valve in the top right opens, the piston goes back up and pushes out the burnt mixture into the atmosphere. But here's the thing, the release of that burnt mixture, also called carbon monoxide, can be harmful for the atmosphere, which is why engineers are always looking for and researching ways to improve these engines and search for alternative power sources. You were able to see some super slow motion clips of the 4-stroke engine cycle, but in reality, this cycle happens thousands of times per minute, and check out how often 4, 6, or even 8 of these cylinders work together in a system. And really reflect on how amazing it is that a simple gas was converted into rotational motion through a series of chemical reactions and energy transfers. So we hope you found that interesting. And now on to a topic that definitely does relate to your project, called friction. And friction's definition is the resistance or force created when 2 objects are rubbed against each other. A quick fun fact is that friction actually creates heat. If you press your hands together and rub them really fast, you'll be able to feel it for yourself. So the more friction you have, the more that force is created, right? And the harder it becomes for those objects to move. Can you quickly pause this video and ask yourself, in this car project, is friction good or bad? Or maybe both? The way we look at it is kind of both. See, on the back wheels, we don't want them to slip and lose that energy. We want the back wheels to have a little bit of friction that grabs the ground and propels the car forward. But some of the moving parts, like the axle, when it's spinning around in the straws, we want that to have as little friction as possible, so there's less resistance. Hopefully this quick clip helps clear some things up about friction. And hey, if you found friction at all interesting, believe it or not, there's a whole field dedicated to friction. It's called tribology, and we'd really encourage you to look it up and check things out. Their line of work is very interesting because, believe it or not, it can actually be a matter of life or death. Remember how we said that friction creates heat? Well, tribologist's job, for example, can be to make sure that that heat doesn't get hot enough to cause an explosion or a fire. Lastly, we'd like to share with you all a principle called mechanical advantage, which says that force and distance are inversely proportional to each other. And all that means is as one gets bigger, another one gets smaller. Take this bolt cutter for example. I'm going to attempt to cut this hook in half. At first, I put my hands nice and close to the cutting part, but had no luck. But when I grabbed it by the handles and got some leverage because it was further away, I was able to cut it pretty easily. Bolt cutters are a great example, but so are things like wrenches, where you put your hand and twist from further away from the screw, and that helps minimize the force required to turn it. We will show you in the next video how mechanical advantage is relevant to your project, but a couple quick hints are, they relate to the size of the wheels and the length of this lever arm, which helps disperse the force. But before we let you go, we have one more quick question. Can you pause this video and think, how does this mousetrap store energy? And when it's released, what type of energy transfer takes place in the mousetrap car? So this is the mousetrap's resting position, and as we coil it back, this spring stores potential energy, and as you guessed it, when we let it go, just like anything else that moves, that potential energy gets transferred into kinetic energy. Well, thanks for your time, everyone, and now that you know some of the science behind the mousetrap car, it's time to learn how to build one for yourself. So we'll see you in the next video where we're going to share some of those tips with you.